Hello everyone, my name is Ananya and today I'll be presenting Milestone 2 of the Aethermart project. In Milestone 1, I focused on setting up MariaDB, designing schemas, doing ETL ingestion, then doing some advanced SQL. But in Milestone 2, I will be focusing on scalability and flexibility of our database. So the thing is that Aethermart is growing very fast. That means there are two major challenges for data management here. The first one is high transaction volumes. That is, thousands of customers are placing orders at the same time. And the second problem is unstructured data. We're getting customer reviews, there are flexible product attributes, there are different kinds of feedbacks which actually don't fit into rigid tables, right? So there was a need to combine the reliability of SQL with the flexibility and scalability of NoSQL. And that's why we are doing this milestone. So in this milestone, my focus will be on four major parts. The first one is triggers. We'll implement some triggers that will ensure data integrity. Then we'll discuss about NoSQL. Like we'll understand that when to use non-relational databases, what are some benefits of using NoSQL, and how we can relate them to Aethermart. And at the end, we'll discuss about partitioning and column store, how these two things can make our database more efficient in terms of scalability and performance. So I'll quickly start with triggers. So basically, a trigger is a special SQL code that runs automatically when a certain event happens. They are used to enforce rules, prevent bad data, and automate some, logic that uh, that we cannot basically directly put into some SQL statements. So for Ethermart, triggers are crucial for managing the complex relationship between orders and order items. And the triggers that I have designed are there will basically ensure financial accuracy and data consistency in the transactional data. So I can say that by enforcing these triggers, we can guarantee that every order is processed with correct pricing and accurate total pricing, regardless of the application or process that modifies the data. So there are these three triggers that I have implemented. So I'll begin with the very first trigger that ensures the pricing integrity. So, for example, consider that I have a product A in the product table with a pricing of $10, for example. Now, if someone purchases this product and that order entry is entered in the order items table with a different price, for example, maybe $20, then there is this data inconsistency, right? The same product cannot have two different pricing. So that's why this trigger will ensure that before any data is inserted in the order items table, it will ensure that the price of the order mentioned there, that means the price of the order that is bought, is equal to the price of the actual product. Um, so the tables involved in this trigger are order items and products. And as I said, that this um, trigger will get triggered before an insertion happens in order items table. So basically, before a new order item is inserted, it fetches the price from the products table, and if both the prices doesn't match, it will give us an error. So if you see here in this screenshot, you will see that a trigger is created. We are fetching the actual product price that is in the products table. Then we are fetching the price that was there in the order items table. Like the whatever price we are going to insert in the order items table. And if both the prices are different, then it simply gives us a error message that says price per unit must match the current product price. So this way it enhances the consistency. Now, the second trigger that I have created is responsible for maintaining financial accuracy by automatically updating the total amount in the orders table. So, for example, consider that there is one order with which multiple order items are related, right? So, this trigger ensures that whenever a new order item is inserted in our database, the total amount in the orders table gets increased by the amount of the product that was just entered in the order items, right? So here the tables involved are order items and orders. This is triggered after an insertion on order items. So basically, whenever a new item has been successfully added to an order, the trigger calculates the sum of the quantity times the price of that particular unit, and then it updates the total amount column in the orders table so that we get the exact idea of how much amount is this particular order of. So if you see the code in the screenshot, it like uh, we started by creating a trigger, then we are declaring a variable that will store the actual amount. That means it will do some calculation and store this into this variable, and whenever there is an insertion in the order item table, the orders table gets updated and the total amount is replaced by the actual amount we calculated, right? So this way we can automatically update the total amount and um, like uh, follow the consistency. Now, the third type of trigger is something that will provide an additional layer of data validation. So basically, this trigger serves as a fail-safe to ensure that the parent table's total amount is always in sync with the line item. So, for example, there is this order, and there are five different order items in that particular order, right? Now, the total amount of that order should be equal to the sum of all the amounts in the order items. So this trigger checks that, and if that thing is not happening, then I will get an error. Um, so order items and orders are again the tables involved in this trigger. The event is after insert. So basically, whenever a new insert is happened, it will run as a quality check that if the total amount is equivalent to the sum of all the orders. Um, so here, if you see the code of the trigger, you can see that we have some variables declared. We are calculating the sum of all the order items, and then we are comparing it with the amount that is present in the orders table. And if the amount is right, then nothing happens. But if there is some discrepancy, it throws an error that the calculated order total doesn't match the stored total amount. So that way we'll know that our data is faulty. There is some kind of issue with our data, right? So now I will show you the implementation of triggers. So basically, I have already made the triggers here. We'll just see and validate if the triggers are working fine. So the first trigger was um, was before insertion into order items, right? So whenever an order is updated in order items, it ensures that the price is same as that in products. So for that, um, what we have done, like to check if the trigger is working fine, we queried some tables. So here's the order items table. Here's the here was the product table, and here if you see, I'm inserting some data in order items, right? I'm inserting order of product 101, that is product 101, and the price of this product is 955.53. So this entry should be successfully inserted, right? Because the price is right. Let's see if this works fine. If I press enter now, I see. Okay, so here's an issue with the table name. So I'll quickly correct that. And then I'll again run the command, and we'll see that this data is actually inserted in the order items table because the values that we have given were right. Okay, and now I'll check if the data is inserted. I'm doing order by one DESC because the order IDs that I've given are like the maximum IDs. So earlier they were 27249 records in my order items table, and the new entries that I've inserted, here I've incremented the order ID by one. So that's why I just wanted to see what is basically the last row. So this was the last row that we've just inserted. And here if you see, I inserted another um, data, and now I have changed the price. So the product ID remains same 101, but I have changed the price from 955 to 960, and it shows me an error that price per unit must match the current product price. So I cannot enter this data into my table because it is not consistent, right? The product value mentioned here is not same as the product value mentioned in the products table. So that's why um that's where this trigger is helping. Now moving to the next trigger. So our next trigger was um the trigger uh, that was inserted after inserting a new item. So basically, it recalculates the order total amount automatically. So here, if you see, the I have selected the order which has the order ID 18,000, right? And here, what I'll do is I will insert another order with a different amount, and then I will again check the order table, and I will see if this total amount is updated. So if you see here, I am inserting some random data in the order items table with the order ID of 18,000 and the price that is mentioned in the product table, because if we mention some other price, then um, this will give us an error because of our first trigger. So I see there is again some error, so I'm fixing that. And after fixing that error, when I'll insert this order into order items, it should get inserted, right? Yeah. So one row affected, that means our data is inserted. Now if I'll check the orders table again, so you see that the amount has changed. Now the amount is 12,367. Earlier the amount was 10,456. So this is something that our trigger has done. There was um, no other code that was written in the SQL that would do this. Um, I'll check again. I'll insert another order and see that the total amount is affected, right? So I inserted again and I'll check the orders table now. I see that the data is now changed to 13,000, which earlier was 12,000. So this is the implementation of the second trigger. Now the third trigger is basically a validation sort of trigger where it checks that the order uh, total price matches the sum of its items, right? And if it doesn't match, then it raises an error. So for this, I have done some sort of negative testing, I would say. So I basically um, dropped the second trigger that I just showed you because eh, because I wanted some inconsistent data, right? So that's why I dropped that trigger because I deliberately want that the total amount should be different than the amount that I've entered. So I'll just query orders table and see the amount. I'll maybe forward it a bit. Yeah. So here you see the amount is 3968, right? So now I will insert an entry in order items with a different price that was not of that product. And for this only, I have um, dropped that table so that I am able to insert this order entry. So once I do that, it says that the calculated order total does not match the stored total amount. And that's what we wanted, right? Because I ordered a different value in the price, and it basically did some internal calculations that I've showed you in the code. And because it didn't, the total sum of all the products didn't match with this total amount, it throwed me this error. This was the price per order item, and this was the order ID that was related, right? So for this order ID, the total amount was 3968. But in order items, if we take a sum of these two entries and of the one entry that we just entered, it is not same. That it is not same as that it should have been, right? So that's why we are seeing this error that the calculated order total does not match with the stored total amount. So basically, um, these triggers ensure data integrity, financial accuracy, and consistency, even if data is entered from multiple apps or sources. Now, I just queried to show you the different triggers that I've made. So this is the before order item insert trigger. This is the after order total check trigger, and the update trigger, right? I've dropped that to check this third trigger. That's why we couldn't see that. So these were triggers. Now moving forward, we'll talk about NoSQL. So NoSQL stands for not only SQL. Basically, it's not against SQL, but it is just that the approach is different from that of SQL. So basically, it is an approach that provides a mechanism for storage of data, not in tabular form. So right now in this, internet world, we get data in lots of different structures. There is no particular structure to data. So there is a need of some database which can store that kind of data. So there comes NoSQL. So it is designed for flexibility, scalability, and high availability. And in our case, we actually want to handle unstructured data. So here NoSQL provides the flexibility to accommodate diverse data types, um, and it enables the business to adapt quickly to the changing market demands and preferences of customers. So the motivation of um, adopting NoSQL was that there was a need for horizontal scalability. That is that we could not, we cannot just add on the RAM, and we cannot just add on the physical devices to enhance our database vertically, because that is expensive. We need a horizontal scalability where we can have multiple servers in parallel, and um, like that the data handling is much faster and much inexpensive than vertical scalability. So basically, we can scale our business horizontally. Then we needed some flexibility in handling unstructured data. Then there is high availability and fault tolerance in NoSQL. So what that means is, for example, um, my data will be stored in different servers, right? In different nodes of NoSQL. So if one server goes down for some reason, I can still get the data from some other server. Then the last thing why we needed NoSQL was because the data was big. Like the volume, velocity, variety, everything was humongous, is humongous. So that's why we need NoSQL. There is this CAP theorem, which is a fundamental rule for distributed databases. It says that you can only guarantee two out of these three, um, you know, whatever these three words, keywords. So we can either have consistency, availability, or partitioning. So consistency means every user sees the same data at the same time. Availability means the system always responds even if with slightly outdated data. Then the third one, partition, means the system keeps working even if servers are split by network issues, right? And it says that we can only guarantee two out of these three. We cannot have all these three at once in our database. So we'll have to do some kind of trade-offs. And like when we need what? For example, banking systems choose consistency and partition tolerance. That means they want accuracy over availability, right? For social media or e-commerce, availability and partition will work better than consistency, because speed and uptime is needed even if um, data updates may take a few seconds, just for an example. So for Ethermart, availability is critical, right? Customers must see products and place orders quickly, even if review updates take a bit longer. So, therefore, for us also, availability and partition tolerance um, are more important than consistency. Sorry. Um, Now we'll discuss some types of NoSQL databases we can have. So, mostly for Ethermart, we'll be discussing key value store, and then we'll be discussing the document model. So, what is key value store? It is basically as simple as a hash map. So we have keys and we have values for their keys, like a dictionary. For example, session ID is mapped to user ID, and then session ID can also be mapped to expiration time at the same time. So this makes the lookups very fast. I mean, Um, in hash maps, we can just go to the key and we can at the same time find the value, right? So the lookups are fast. These are great for sessions and just something that we need quickly. Um, these are some examples that I've given, like session management can be one use case. One use case can be product availability caching. So basically, stores frequently change inventory data, right? They can do it in a key value format. So, for example, if a product is in stock, out of stock, and what is the quantity, because we need quick checks. Therefore, key value store are very efficient in these kind of scenarios. Then we have our document model. Um, document model is nothing but as a document, right? So it stores data as JSON documents. For example, reviews can be stored like this, and products and attributes can be stored like this in particular documents. So every document doesn't have same attributes, because in real world we cannot have every data with the same rows and columns, right? We will have different attributes for the data. So that's why we are storing them into a particular document. So this provides flexible structure. There is no need to redesign schema for every new product type. We can just simply put some data related to one particular product in one document, and that's it. Now we'll talk about partitioning. So partitioning is basically splitting a large table into smaller logical parts, but still treating it as one table. There are two types of partitioning, horizontal and vertical. Horizontal means we will split row-wise. Structure will be same, but rows are divided into chunks based on some rules. And in vertical partitioning, we split data by columns. In the way I did is we had to do the horizontal partitioning, right? So basically, I created this SQL script to partition. We basically I'm partitioning the table orders. So we have a table called orders, right, in which there are multiple orders given, and there is this date related to every order. And we are doing the partitioning on basis of the year. So basically, um, if you see, sorry, if you see here, you'll find different partitions based on years here, less than 222, 23, 24. So we have partitioned data in orders based on years, and then once I run this SQL file, and then once I go and see the data in my partitions, as you will see here, I see that in the 2024, and P max means after 2025. So I have data only in these um, partitions. There was no data for other partitions in my data particularly. So we basically divided our orders table into all these partitions. That makes easier to scan our database. So the performance becomes much faster. The old partitions can be archived if we want, and it is basically scalable. It supports massive growth. Um, as I said, that benefits will be faster queries, it is easy to maintain, it is scalable. Now we will talk about column store evaluation. Column store is a special storage engine in MariaDB designed for analytics. So basically, for example, if someone asks the show me details of order 102, that kind of thing will go into row-based storage. But if someone asks that um, you know, what's the total revenue by day, then column storage is helpful. So this is a good example of the row-based storage and column-based storage. So these are great for transactions like these, and these are great for transactions like this. So for Aethermart, column-based storage are very useful for analytics because there are huge number of data, huge number of orders, reviews, which can be analyzed quickly. We can simply go and find out how much was the total revenue, right? We can quickly go and find out uh, some data about the reviews and all of that. So column-based storage is perfect for dashboards and reports and basically business intelligence. Um, so this was the milestone 2. Now, disclosing AI. So I use ChatGPT for many things. I used it for explanations, for SQL examples, for visuals like this visual I've made from ChatGPT. So it helped me in structuring my PowerPoint slides, also creating visuals. For coding, also I've used AI to give me some idea on how to, make like fix things and all of that. But um, there was always some correction needed. For example, I had to correct some partitioning syntax for MarioDB, and I had to adjust some logic for triggers. But definitely, I made it very faster and it improved clarity. But raw outputs were not actually fully accurate. With corrections and testing, it acted as a co pilot, while the final responsibility for correctness was actually mine. So, yeah, that's the end. In summary, I implemented triggers, no SQL strategies we discussed partitioning, a column store, and at the end we discussed about AI. So that's it. Thank you so much.